All right, so in this podcast, we're going to talk about metric prefixes and how they can be used in dimensional analysis along with other conversions that we're given. So this is mostly going to be page 16, but then there's just a couple problems at the top of page 17 that we're going to address as well. So let's get started. Here's your metric prefixes. At the top of the page, you have a place to write down some of the base units. We already defined base units in our last podcast, actually. So these are just some examples of base units, because all of these base units here can get these prefixes put on them in order to make those prefixes bigger or smaller to fit the situation. So here in this graph or kind of chart that we have on the page, all of these units up top can be represented by that base unit. And so we can have meters or kilometers. We can also have kiloliters or kiloseconds, kilograms, kilomoles, kilowatts, etc. So these are all just prefixes you see in this chart that are going to make our units a little bit bigger or smaller depending on what we need. Now, it does say you need to know them, but you actually don't need to know them all. The ones that we need to know, there's 5 of them. Kilo, of course, very common. Mega, meaning million. And then centi, milli, and micro. Those are the 5 that I need you to work on knowing and remembering. But I don't want you to just remember the names. I want you to remember what they represent. I want you to be able to use them in some dimensional analysis. So let's get into how we will use those prefixes. Right underneath that prefix name, or the word prefix, is the symbol that goes along with it. And then there's that number, and that's the number of base units in one of those prefix units. So if you look at centi as an example, it says 10 to the negative 2. There's 10 to the negative 2 meters in 1 centimeter. What you're really doing there is taking that number and saying that many of our base unit. I've just used U here because remember, that could be meters, or it could be grams, or it could be liters or moles. As long as it's the same on both sides, that unit goes here. So there's 10 to the negative second meters in 1, and then we take the symbol here, centi, whatever unit we've got. So you can use this general format in order to write these equations, and these equations are going to be what we use in dimensional analysis. Now, some of you might be thinking, well, 10 to the negative second meters in 1 centimeter, that's not what I would remember. I remember that there's 100 centimeters in a meter, and that 100 is 10 to the second. So sometimes our perspectives, especially if we have a history with some of these prefixes, we might already know some of these unit equations. And I don't care which one we write, but sometimes it's harder to come up with them either way. And I'll talk about it more in class when we get back together about how I remember them and kind of help you figure out how you want to remember all 5 of these conversions. But no matter how you do it, you can switch that exponent's value, so 10 to the positive 2, and make it that many centimeters in a meter. But if we switch the sign on that number from our table, we also have to switch where that prefix is. So it starts to get a little bit complicated. So we'll talk about it a little bit more in person. But no matter which way you view it, and you have 2 different examples there. Those 2 examples that we see here are equivalent to each other. All we've done is switch the sign on that number and then switch that number from the meter side of things to the pico side of things. So we just kind of switched things. And even if you don't prefer that scientific notation type view of that number, you could even think of that same conversion as a whole number, remembering 1,000 grams in 1 kilogram instead of 1,000th of a gram of a kilogram is 1 gram. Just depends on what fits better in your brain. So we'll talk more about those, but we do want to be able to practice getting those and using those in dimensional analysis. So that's what we're going to look at with the rest of our page today. So I'm going to practice, before we even give you any numbers, trying to find these equations, these unit equations, in order to use in some dimensional analysis problems. So this is just going to come back to, I'm going to use this kind of general format that I've already given you with this table in order to come up with the conversions we would need if we were given something like 542 kilograms. How many grams is that? That kind of thing. So here, when you're looking at conversions, remember we're going to have the same base unit on both sides in order to convert from a prefix unit to that base unit. So first start by finding what that unit is. Find what's the same on both sides of your conversion. And here in that case it is grams. Now what's not the same is going to be your prefix or prefixes. So here I can see that there's a K left over, which means I'm dealing with a kilo unit. So I'm going to take that 10 to the third, and that's the number of our plain old unit, grams, in 1 kilogram. And that's our equation that we're going to need to use in dimensional analysis. It's that simple. Now, the next one's a little bit more complicated. When we look at these units, finding what's the same on both sides is our M for meters. Both sides of this conversion have prefixes on it, which means we're going to need an equation for each of them to use in our conversions, in our dimensional analysis. But that kilo conversion is going to be very similar. Kilo is still 10 to the 3. Our unit this time is just meters in 1 kilometer. And then pico's number is 10 to the negative 12th. And we're still going to put that same unit, meters, in 1 picometer. So those conversions, this and that, are the two that we're going to need. Last but not least, we got this funny looking symbol here that is micro. So I'm going to change colors because we're getting a little squished together down here. Micro is 10 to the negative 6th. And I could definitely tell that that prefix was there before even looking at my base units, but I need to find those base units so I can write my equation. Liters equals 1 microliter. And then it looks like I also have centi here. So 10 to the negative 2, nope, not centiliters yet, just plain old unit in 1 centi unit. So just wanted to practice putting these equations together without any numbers being involved, any calculations, just finding those using the chart. So let's go ahead and look at some problems where we are going to have to do some conversions, some calculations. So here, we've got the same general format, except instead of an arrow, we have an equal sign, and one of these sides has a number that we're going to be using to convert. So first, we're going to get our equations ready so that we can use them. Looking at the units only, seconds to milliseconds. I can see the seconds part is the same, so the conversion I'm going to need here is that 10 to the negative 3 seconds is 1 millisecond. And that's it. So now I'm going to do some dimensional analysis with that. I'm going to take my 25 seconds, that's my given, that's the side with the number. And since seconds was on top, I need to put seconds on the bottom of my next bracket. So I'm putting the 10 to the negative 3 seconds on the bottom, 1 millisecond on top. And what this tells me is that I need to do 25 divided by 10 to the negative 3 to get my answer. And my calculator tells me that that answer is 25,000, or 10 times 10 to the negative 3. And that does have 2 sig figs just like I started, so I just need to make sure that I get my final units on it. And that's done. That's it. In this next problem, looking at the units that are the same, helps me see that I have that N there, which is my prefix, so that's my nano. So 10 to the negative 9th meters is 1 nanometer. That's the only prefix I've got. That's all I should need. Now I go to set up my dimensional analysis with my given first. Nanometers would be an nm. And then I'm going to take the nanometers part of my equation and put it on the bottom I'm not sure why I keep forgetting my nano. And then 10 to the negative 9th meters. And when I put this in my calculator, my answer actually becomes 3.52 times 10 to the negative 7th. So, still scientific notation because this number is so small that my calculator could not show me all of those digits. And I do need a meter unit on there to finish that up. But that's all that I need in my dimensional analysis. Now, as we're looking at this next one, we notice that our grams are our base unit, and I've got kilo and pico prefixes here. So I'm going to need two equations. And these are incredibly like the kilometer, picometer equations that we came up with when we were just practicing conversion factors. The only difference is that this is grams. So now, when I'm looking at my given 5.30 times 10 to the 14th. Sorry about that. Getting picograms on there. Now, looking at all my options here, I have to choose the equation that has picograms in it so I can keep my dimensional analysis going. So 1 picogram goes on bottom, 10 to the negative 12th grams goes on top. Remember, we have to keep those specific units together from that equation. And now those grams give me that bridge in order to connect to my next prefix conversion unit. Because I've got plain old grams on top, I can put these plain old grams on the bottom, and then 1 kilogram goes on top. All my units are set up correctly, and now my final answer comes out to a nice round 0.53 kilograms. So, not too bad, I hope, even doing two conversions there. Okay, now we get to some real conversions that we're going to be doing with kind of words involved in it, and this isn't going to be too bad, but we've got to think to be able to connect all of these things. We've got a 1,650 meter pool. We're trying to find feet from this. So we've given you one conversion here, the fact that 2.54 centimeters equals 1 inch. That's something we'll give you on tests and quizzes as well. But if I'm starting from meters, I can't use this conversion immediately because this is giving me centimeters. So the first thing I absolutely know is that I have to write a centimeter unit equation. That's something that we need to be able to have in our back pocket as one of our tools. Remember, that's one of the conversions we need to memorize. And not all of our problems are just going to give us every conversion that we need. We've got to be able to come up with them. But even then, notice the meters can get to centimeters, and then centimeters can get to inches, but it's asking for feet. So I am going to have to come up with one more conversion to use, and that's a simple one. 1 foot equals 12 inches. And now we're going to set this up starting from that 1650 meters. And then 10 to the negative 2 meters in 1 centimeter. 2.54 centimeters in 1 inch. And then 12 inches in 1 foot. That's all that we need here. So, multiply this stuff together, divide by the bottom, and see what answer you get out. If we think about this answer, it should be a really big answer. So, don't be surprised when your answer gets kind of big, but do try your best to round that to 4 significant figures. I'm also going to leave you question number 9 and 10 that are there. If I can get that to pop up, I had to get the other stuff to disappear first. So, this is back to just being a simple unit conversion problem, as well as number 10. The units are a little bit weird and there's some more words in there, but you use what you've got in your chart in order to help you set up and work out those problems. Come to class with questions if you got them. What I really want to spend a minute on is question 11, because this has something that it was in your notes up there by that chart, but we skipped over it because it wasn't really about metric prefixes and I didn't want to confuse you yet. This conversion, the fact that 1 centimeter cubed, 1 cubic centimeter, like if I took a cube that was 1 centimeter on every side, that much water is 1 milliliter of water. That's the definition of a milliliter. So anytime you see a problem that has some of these weird cubed units to normal units, you're going to have to use this equation. So if I'm already planning that out, I'm going to use this equation over here. I already see that I'm going to need a couple other conversions to go with it, because I have centimeters cubed here, but then meters cubed there. So I'm going to need a centimeter to meter conversion. And we've done these a couple of times. And then I also don't want milliliters as my answer. I want normal liters. So I'm going to have to write a milli conversion with our liters. And now this should be all that I need in order to set up and solve my problem. So let's start with our 430 meters cubed. And then I'm putting my meters on the bottom to 1 centimeter. And hopefully in class we've already worked out a problem like this where we are given something squared or cubed and our conversion factor is not squared or cubed. All we've got to do is cube those units and cube these numbers. So 1 to the third is still just 1. And 10 to the negative second raised to the third power is actually 10 raised to the negative sixth. So if we change that, then we've got the conversion that we need with those cubed units on it. And then we're going to go from centimeters cubed to milliliters like we planned. And then 1 milliliter is 10 to the negative third liters. So that gets us all the way to our answer of 430,000. Now, this is going to be kind of hard to have 3 sig figs unless we put this back into scientific notation. So that's 1, 2, 3, 4, 5. So 4.30 times 10 to the 5th liters is the answer there. So make sure you do those 2 problems that we skipped over. At least give them a try and come with questions, because we've learned basically all the skills that we need so far, and now it's just about practicing them and putting them into use.